Welcome to ChemTutor Pro. Today, we're diving into the first law of thermodynamics, the foundation of energy conservation. This law tells us energy can neither be created nor destroyed, it can only be transformed. By the end, you'll understand internal energy, heat, work, and key processes like isobaric and adiabatic. Let's get started. The first law is simple yet profound: energy is conserved. Think of it like a budget. You can't make money out of thin air, but you can convert dollars to euros. In thermoterms, total energy in a system stays constant, just changes form. This leads to our key equation. Change in internal energy, delta U, equals heat added, Q, plus work done on the system, W. We'll break these down next. First, internal energy, U. This is the total stored energy inside your system, like a gas in a container. It's the kinetic energy from particles zipping around plus potential energy from their positions and interactions. Internal energy depends only on the system's state, like temperature and volume. Not how it got there. Next, heat, Q. Heat isn't energy inside. It's energy moving because of a temp difference. Imagine a hot coffee mug warming your hands. Heat flows from hot to cold. Positive Q means heat enters the system and negative means it leaves. Look at the diagram. Heat absorbed by the system. Work, W, is energy from organized motion, like a piston pushing gas. The formula is W equals P delta V, where P is pressure and delta V is volume change. Sign convention: positive W means the surroundings do work on your system. Example: compression shrinks volume. Negative W means the system expands, doing work by itself, like a balloon inflating. This matches our delta U equals Q plus W equation. This is a simple technique to remember the quantities and their directions. Positive Q is heat absorbed or endothermic. Negative Q is heat release or exothermic. And positive W means work done on the system. Negative W is work done by the system. You can use this simple technique to solve any questions related to first law of thermodynamics. Now, apply the first law to four processes. First process is isochoric system. It means constant volume. So, no volume change. P delta V equals 0. Work, W equals 0, then, delta U equals Q. Second process is isothermal, constant temp for an ideal gas, which means the delta U equals 0. So Q equals negative W. Third process is isobaric, constant pressure. No changes for the equation. The fourth process is adiabatic, means no heat added, so Q equals 0, then delta U equals W. These are building blocks for engines and reactions. Let's look at the relationship with the ideal gas equation. Isobaric means constant P, equation is delta U equals Q, P, plus W. Think boiling water at 1 atm work is W equals negative P delta V. But Q at constant P equals enthalpy change, delta H. This relationship is super useful for reactions. Substitute Q by delta H. Then, delta U equals delta H plus negative P delta V. Then substitute P delta V by nRT. The approximation delta H is almost equal to delta U plus RT delta N. If gases increase, which means delta N is higher than 0. Delta H will be higher than delta U. Chemists love this for standard enthalpies. Let's apply it. Suppose a reaction in a piston. Pause a minute and try to solve the problem. The system does 150 kilojoules of work expanding. So W equals negative 150 kilojoules. This is isobaric. Plug into delta H. Real world, car engines balance Q and W for efficiency. Delta U is negative 802 kilojoules since this is an exothermic reaction, then Q will be negative 652 kilojoules. To wrap up, first law equals conservation of energy. Master U, Q, W, and processes, you're set for thermodynamics. Remember signs: compression adds energy via plus W. Subscribe to the channel for more exciting chemistry tutorials.